Yeah, good afternoon, everyone. Thank you. Again, for being here. Quite humbled to be, like in the presence of so many talented people, and it's great to see what you guys are all doing. And this sort of space is what we need a bit more. I'm just gonna jump a little bit on our journey. It's been quite small so far. We founded Alter last year, so I'll just show you a little bit our journey through building configurators, automation, and AI for mass customization. Now, we leverage a lot on our core business through automated design solutions, enhanced virtual experiences, and user participation in the form of exterior and interior configurators. So we provide different bespoke solutions that are all cloud-based, could be real-time rendered, and we basically create a full software stack of solutions that, depending on our client's need, we can adapt to. Now, one of the things that we've touched today, I think, at some point is like, why are we doing this, right? Like one of the things is to do things faster, cheaper, but we are very interested to making things better. So one of our main objectives is also with this technology, we can actually go towards a mass customized future. And then this is not ideas that are necessarily new. Christopher Alexander, back in the 70s, he wrote a book called The Pattern Language. Neufert as well, back in the 1930s. Probably if there are any architects, you've been exposed to one of these books. So this has been very computational. At the time, there was not the technology, but this is all rule-based. How can we encode architecture into a set of rules? It's all ergonomics. It's all space-oriented. It's a system of relationships, right? So on top of that, the construction industry, especially the offsite sector, has learned a lot over the past decades out of the automotive industry. Back for Henry Ford's assembly line on the 1920s, which was quite disruptive. But there's still years ahead to still learn about fully automated factories. And some things that have pop up in different conversations is about engaging buyers and mass customizing the feature and the product, right? Like, so we can see in a way buildings that could be configured differently. So that's something that we start adopting as well in our core value. So a lot of these digital twinning simulations that these companies are creating bespoke to them, then are helping them design and simulate their next prototype is something that we have to embrace and learn. Now, we stand up on the shoulder of giants. I started this journey after having a good career at Zaha Hadid Architects in the computational design group, where was exposed to many projects back from competition all the way to construction. And then we had to create bespoke software to generate a lot of these complex geometries and also create, I'll show you a couple of them, but one of them is a configurator for modular housing, even though it doesn't look like. But it was like this intersection of knowledge that helped out set the foundation of Alter. Now with these projects, again, is a project is made in Roatan, Honduras island. So it's basically a small community of residents that came together, all modular, all made in timber in a robotic factory that is going to be shipped into the site. So in this case, we created a configurator just to understand a little bit the requirements of the people that are going to live here. So they had the option to actually select where do they want to place a unit in the stack. And this was, we as architects, we didn't want people just put whatever they want the unit in this location, but this just served as a data gathering mechanism, so we can start kind of like laying down what are the options. If I prefer a wide layout or a loft unit, if I prefer to spend a little bit more on having a bigger terrace or a palapa roof, and then all this data actually then helped out design and then put all together a community it came together cohesively, but also respecting what the people in this community was interested about, right? So it's about generating better designs through this system and through all the kit of parts that would assemble these projects. Now, another project which was quite fond of. Like this took less than 3 years to design, from competition all the way to construction. And it was only possible out through computational design tools. The input of the whole stadium was only one curve. So reconstructing all the geometry all the way to the bolt and all the parts, and having different AI clustering algorithms that would help shape and start finding families and rationalize all the design into a, basically, I mean, you could even call it like a little kit of parts or components, but while always respecting the final design intent. So back from the louvers or all to the paneling roof, that's kind of like all that knowledge, wrap it up and create it alter. So the first demo was still at CitA when I put this one together. So it was basically collecting data from OpenStreetMap. So you can start generating, reconstructing different areas of the city, and then you can start selecting one site, and then based on different zoning variables, an evolutionary algorithm would start just to optimize different metrics of, in this case, were financial metrics, but also like within the bounds of the zoning regulation, and also within radiation constraints. So it's basically also analyzing solar radiation while it does all the analysis. But also as a user, you would want to override the system, so you could actually manipulate the parameters within a very easy to use UI, so this is all cloud-based as well. But then very quickly, from a specific massing, you can then have all the components out of a kit of parts, then just mapped, and you can swap very quickly between different architectural styles. Now, the next module that lives separately is basically this tool that you can then start engaging with off-plan sales, or as a property manager, you can start bringing in different people. And then we can start establishing the rules, whether do we want to allow some sort of flexibility in the layout without affecting any MEPs or structure. And then having inbuilt interior design templates pre-curated, connected to databases of home suppliers, so we can very quickly allow a customization of the users, and then experience each of these units as a first-person viewer in this property. So it was like an enhanced experience, just that you could be in any location of the property and see what the view would be, what your neighbors or your prospective neighbors are actually doing in their spaces. Now, it kind of like all of this wrapped in the vision of making expert design accessible to anyone. Anyone could be literally like anyone. And then the mission is to create those better design spaces, sustainably built, uniquely tailored to meet all those individual needs. Now, we provide catered solutions to different stakeholders, all the way from the developer to offsite manufacturers, architects, home suppliers, all the way to the final homeowner. Now, we stack these. We basically have a core technology that is modularized, and it can be grouped in these 3 big themes, which is generative design up to the planning stages of a project, all the way to a connected configurator, and then it's basically living on its own, a pseudo digital twin, and it doesn't have all the sensor information, but it's something that lives and connects and engage with the stakeholders and buyers early before it gets built, or even with some of our clients are using it to manage their properties. Now, one of the things that is important is we have realized is how do we encode architecture and how do we encode a building? So we've been kind of involved with academia for a while, and then one of this is also not new, and a lot of technologists and people that know a bit of software systems would be familiar with graph systems and graph theories. So a system of connectivities, and then that's the way that we have been abstracting a building and an architecture, and then that's the way that we've been serializing all our data into a set of components that has a set of relationships not only between themselves, but also between the urban context. So that way we can very quickly and very easily start computing different options of layouts for different buildings, to start computing different fire escape distances at different scales, and also to the layout of each of the units, where we can start then identifying or quickly generating, procedurally, all the interior walls for any property, and then each interior or each wall would know if it's an interior, if it's an exterior, if it would have any MEPs associated. So all the labeling on everything process that's been done manually, we can just encode. So these we can adapt to anyone. So one of our clients, they do modular housing. They're focusing on PBSA, on student accommodation. So we've created a system that just can quickly adapt to any site, any condition. It will start computing fire escape distances. It can start also mapping or adjusting to consented schemes or different sites, and it will start running different generative evolutionary algorithms as sort of an AI as well, that it starts optimizing, finding those correct parameters to maximize the target. It could be the net sellable area, it could be a target mix ratio, and then it will produce all the kit of components that can be easily exported to BIM. So that way we, as software developers, we're quite interested in speed, so we can go very quickly between levels of details out of diagrams that would just have all the metadata needed to then very quickly iterate and create all the CAD information and all the layouts, but also most importantly in exporting all the real-time data, schedules of accommodation, build of materials at real time. And then very importantly is like we need to allow humans in this case, or either ourselves or either the designers that are using the tools to quickly modify and shape the buildings, and then all information itself, it would be just parametrically reconstructed. Again, being an agnostic software company, we leverage a lot in the data, so we can easily just move all of these components between your preferred software in that sense. So we can export from one to another. In this case, it was Revit. And depending on the client's requirement, we can also then start parameterizing all the building components back to the vault and back how of these set of relationships work. So since the master system would now have the overlay of all the units, then the next level system could then discretize and deconstruct all the components of the units, again, back to the panels, back to the bolts, to get build of materials. Then this is, some of you might be familiar with Midjourney and ChatGPT image generation. Right now you can prompt something and you get an image, but it's quite uncontrolled, right? Like how do we build this? We reversed engineer it in some way. So we've been training kind of our custom generative models in order to match the parametric model in that sense. So that's why we can organically create some of these diffusion models trained to our customers' styles, and also matching the parametric model information. And then that's why we're gonna have a lot of control, so we can always have the same site, the same building view every time we iterate over prompts in different styles. Now, we could also go even further. I mean, we can get OpenStreetMap data, reconstruct cities and in 3D, extract all the diagram information, use analysis, height analysis, and start automating all of these. This has been quite useful for planning applications or site identification for some of our clients. Or we can run, anything that we could compute or that we can quantify, such as environmental metrics, solar radiation, view analysis for each of the units, so we can optimize, or we can train the algorithm to optimize for any specific measure. We are gonna add very soon carbon emissions and wind analysis as well. That's some people that have been interested in. So that's another thing since we are quite young, we're looking out to find this strategic partnership, and these first partnerships are helping us shape the platform to their specific needs. So we want to add value very early on. Now, on the configurator side, let's say our system works through a kit of parts, so that way we can design with our clients a different style set of kit based on different massing options that were done by the generative tool. So from the cloud-based platform, this runs straight from the web. A user that is not, let's say, like technically drawn to CAD, we just create a very easy-to-use interface that they can toggle between all the design studies that have been pushed by the designers. and then they can start visualizing this in a real-time rendered platform. They can run different solar analysis, but most importantly, they can start actually swapping between different kit parts. So you can start seeing how that building would look in that specific location. You can start not only changing the kit, but you can say you want to fix a style, and then you want to iterate it back again through all the massing versions that has all the metadata, all the information of that specific site. And then also start customizing parts if you want to make the building slender, if you want to change some materials. All the CiTA, all the props of the people, trees, it's all procedurally generated, so we can automatically export CGIs out of these. I mean, it's a realistic CGI, so it's something that our clients, before they were outsourcing, now they can have a tool that they can export all of these in-house. And then they can start engaging with different stakeholders. They can even take them to any of the units, and then they can show them inside each of these spaces. So it's like holistically exploring and having a different way of presenting your projects based on data, so you can have all the data of that specific unit and all the data of the whole building out in one platform. And then connected to Cesium and different Google photogrammetry, we can actually start embedding these configurators and into the CiTA and see how it performs on the CiTA. Now, these are some very quick, based on a button, you can generate this quality of CGIs and just start iterating over different styles very quickly. And then lastly is like the digital twin. In this case, we've created a couple of prototypes to some of our clients. One of them is like a twin, basically, CiTA, where depending on what our client wants to expose, in this case, could be like information of points of interest in the CiTA, different facing information of that specific development, so we can lock parts that are not yet available, and then it's connected to either their CRMs, or we can just create basically the back end to have all the management of the units on the back, just showing which ones are available, which ones are not. But then engaging, seamlessly to the people that this is just running through the website, or it could be just running through an iPad in the suite or in the office. You can start toggling between different, so every unit becomes its unique showroom, its unique way of exposing, and it's expressing the design potential of every possible space, right? Like that's what we want to aim, helping tools make better designs for everyone. And then in case like these people or these prospective buyers can then start having, how's the look of that city, how's the look of that specific apartment, how's the solar, the sunlight exposed on any particular corner of the development. And this is like the actual, it's not animated, it's the actual quality that you get straight out. We're leveraging on state-of-the-art game engine technology and running as seamless as possible. And then the last one, which the beta version is just released a couple of weeks ago. So it's for Unilife, it's also like a student accommodation property manager, so they can start connected to their CRM. They can start showcasing to students that are overseas. A lot of their students come from China. So they can allow these in any platform, so they can start visualizing what would be their home for the next year. And it's something that becomes just a twin for years to come, right? It's not just takes information from the built model, but it also goes out through the life of the city. We're trying to see if there's value to add extra levels of information, but definitely we want to take these to be a serious digital twin, so we can have informed decisions based on usage of the building and then informing back the design. So right now, if we could always feed it back into the design and to the system, that's where we're kind of interested in the long term. So yeah, I mean, we're basically helping our clients and our partners to design, build, sell faster, but most importantly, better looking and more sustainably built buildings. Leave some information there if you're interested, and thank you everyone again. Thanks.